Hello students, Stride here again. Today we're going to polish off your notes for our section 10.3 titled Moles and Compounds. At this point you should have done some work with Hummer videos. Here we want to add any additional notes you need. We'll have things we do in class together also. All of these combine together to make your notes. Section 10.3 Moles and Compounds. Our objectives, we're going to want to recognize the mole relationship shown by a chemical formula. Calculate the molar mass of a compound is a very, very important one. Convert between the numbers of moles and the mass of a compound. That'll be very similar to what we did in the last section. Once we learn how to do the molar mass. And apply conversion factors to determine the number of atoms or ions and the known mass of a compound. So a lot of calculation stuff here again. Representative particle, review vocab, an atom, molecule, formula unit, or an ion. Main idea, the molar mass of a compound can be calculated from its chemical formula, and it can be used to convert from mass to moles of that compound. We'll be using what we're going to learn in this section all the way through the rest of the year. Very, very important stuff for chemistry. Molar mass of a compound equals the molar mass of each element multiplied by the number of moles of that element in the chemical formula and the atom altogether. Molar mass of a compound demonstrates the law of conservation of mass. For elements, the conversion factor is the molar mass of a compound. We're looking at converting moles of a compound to mass. Procedure is the same for compounds. Molar mass, this up here should have said element. Sound right. Let's get rid of that word compound, make it the word element. For elements, the conversion factor is the molar mass of the element. Procedure is the same for compounds, except you first calculate the molar mass of the compound. Converting mass of a compound to moles, the conversion factor is the inverse of the molar mass of the compound. So if we have illustrated here, if you have 5.5 grams of a compound and its molar mass is 185 grams, you do, and I'm going to add in my little box, and you do a little dividing and you get 0.02 moles of the compound. Convert the mass of moles to compound with the inverse. A couple other things you want to be able to do, convert mass 2 moles of a compound with the inverse of molar mass, and convert moles to particles with Avogadro's numbers. We'll be doing all this stuff in class, get lots of practice with it, and then you'll have some practice problems to do on your own later. And if you like diagrams, this is a pretty good one. I'll show you the basic ideas of what's going on. We'll also, as we do some questions class, probably draw maybe a little different one. So how many moles of OH ions are in 2.5 moles of calcium hydroxide? So if we got 2.50 moles of calcium hydroxide, and we're trying to figure out how many moles OH ions. So 2.50 moles CaOH2. And for every 1 mole of, oops, got my parentheses over there, CaOH2, we got 2 moles of OH ions. Moles cancel moles. Do a little multiplying. That's where the 5.00 came up with. Yeah. We'll get to practice a lot of these in class. How many particles of Mg are in 10 moles of magnesium bromide? Here we're trying to go from 10 moles of MgBr2, and we're trying to change that to particles of Mg. So we'd be doing 10 moles of MgBr2, and for every 1 mole of MgBr2, we would have 1 mole of Mg particle, and then a mole of Mg particles would be 6.022 times 10 to the 23rd particles. Moles cancel moles. And so we're just taking and keeping the same proper number of sig figs. We actually should only have, with 10 moles, that's really only 1 sig fig, so I'm going to change their answer just slightly. It's 0.022. Wrote down the wrong number back here. So we're just taking that, and it ends up being 6 times 10 to the 24th Mg particles. So we'll get rid of that O2 there. So that's just a quick run through of some of the stuff we've done and we'll do in section 10.3. That's all for now.